Assalamu alaikum dear students. This is our first video about mathematical methods in physics. Okay, in this video we will solve 4 problems. Okay, all these 4 problems have been selected from the book Advanced Engineering Mathematics by Dennis G. Zill. Okay, all these 4 problems relate to vectors and all have been chosen from the book Advanced Engineering Mathematics by Dennis G. Zill. MMP, Mathematical Methods in Physics, problem number 1. Dear students, this first problem comes as an example in that book, while remaining next 2 problems have been chosen from exercises. Okay, it does not make any difference whether we choose example or problem. Okay, we are concerned with the contents. So mathematical methods in physics, problem number 1. Find the distance between a point in space that is 3-dimensional having coordinates 2, -3, 6, that is x coordinate 2, y coordinate -3 and z coordinate 6, and other point having coordinates -1, -7, 4. Okay, that is x coordinate -1, y coordinate -7 and z coordinate 4. Okay, quite simple. We have to use the formula for calculating distance between 2 points in 3-dimensional space. Okay, as we put these values in that formula, we will get the desired value of distance. Okay, solution. We know that distance between 2 points P1 x1 y1 z1 and P2 x2 y2 z2 is given as distance between P1 and P2 equal to under root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Okay, hence distance between points having coordinates 2, -3, 6 and -1, -7, 4 is equal to under root -1 -2 square plus -7 plus 3 square plus 4 -6 square. Okay, because dear students, here -1 is regarded as x2 while 2 is regarded as x1. Dear students, here we have taken square of difference of x2 and x1. Okay, so here x2 is -1 while x1 is 2, y2 is -7 and y1 is -3, z2 is 4 while z1 is 6. Okay, so -1 -2 -7 plus 3. Okay, because 3 is already minus, so it will become plus, because we will write it in this form that -7 minus within bracket -3, and we know that when minus is outside the bracket, it means two minus signs are being multiplied, and we know that multiplication of similar signs results in positive sign, while multiplication of different signs results in minus sign, negative sign. Okay. And similarly 4 minus 6. Okay, so after simplification it becomes 9, which is square of 3, plus 16, which is the square of minus 4. Okay, plus 4, which is the square of minus 2. Okay, the benefit of this square is that we can never get a minus answer. Okay, because square of any real number can never be negative. Okay, square of any imaginary number may be negative. Square of any positive square of any real number can never be negative. Okay, so we have gotten 9 plus 16 plus 4, which is equal to 29 under root. Okay, similar are the problem number 2 and 3, but we will take them as a practice. Okay, because example is always usually 1, and corresponding problems in the exercise are always many more. Okay, so mathematical methods in physics. Problem number 2, find the distance between 3 minus 1 2 and 6 4 8. Here x1 is 3 and x2 is 6, y1 is minus 1 and y2 is 4, z1 is 2 and z1 is 2 and z2 is 8. Okay, so solution, we know that distance between 2 points p1 x1 y1 z1 and p2 x2 y2 z2 is given as d p1 p2 equal to x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square whole under root. Okay, hence distance between points having coordinates 3 minus 1 2 and 6 4 8 is equal to 6 minus 3, because 6 is x2 and 3 is x1, plus 4 plus 1. Okay, because 1 is already minus, so 4 minus minus 1 will become 4 plus 1 square, plus 8 minus 2 square. After simplification it will become 9 plus 25 plus 36, which is equal to 70 under root. Okay, now we come to problem number 3. Find the distance between minus 1 minus 3 5 and 0 4 3. Solution as in the previous two problems. Okay, we know that distance between 2 points p1 x1 y1 z1 and p2 x2 y2 z2 is given as d p1 p2 equal to x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square whole under root. Okay, hence distance between 2 points having coordinates minus 1 minus 3 5 and 0 4 3 becomes equal to 0 plus 1. Okay, because 1 is already minus, so 0 minus minus 1 will become 0 plus 1. Similarly, plus 4 plus 3, because 3 is already minus, so 4 minus minus 3 will become 4 plus 3 plus 3 minus 5. Okay, after simplification it becomes 1 plus 49 plus 4 equal to 54 under root. This 54 can be written as 9 into 6, where 9 is the square of 3, that is 3 raised to power 2 raised to power 1 by 2. Okay, because under root is power 1 by 2, while 9 is second power of 3. So second power of 3 will be cancelled with the under root 1 by 2. So we will get 3 outside the under root and 6 inside the under root. Okay, 3 into 6 under root. Okay, problem number 4. Find a unit vector in the direction of a bold, that is a vector equal to -2, 3, 6. This is angle bracket. Okay, this is just a method of representing a vector. Okay, we are not bound to use this method, that is in which angle bracket is used. Okay, so in the solution we have clarified our view that a vector equal to -2, 3, 6 becomes equal to -2i plus 3j plus 6k. Okay, that is to say, instead of this angle bracket we can write vector a as -2i plus 3j plus 6k. Okay, where I, j, k are unit vectors along x-axis, y-axis and z-axis. Okay, this implies that we know by definition that unit vector is always equal to vector divided by magnitude of that vector. Okay, so a unit vector becomes equal to a vector divided by modulus value of a or absolute value of a. Okay, so in place of a we have written simply -2i plus 3j plus 6k, while in place of magnitude of a or absolute value of a we will take care of all the three components. Okay, that is under root 2 square will become 4, 3 square will become 9 and 6 square will become 36, and after adding we will get 49 under root, and we know that 49 is the square of 7, so 49 under root is equal to 7. So our unit vector a cap, this symbol is usually called cap. A cap, that is a unit vector, becomes equal to -2i plus 3j plus 6k divided by 7. Okay, 7 is the magnitude or absolute value of vector a. Okay, we can write 7 separately below x component, y component and z component. Okay, so it becomes equal to -2 by 7i plus 3 by 7j plus 6 by 7k, and in the last we have again converted it in the pattern in which it is given in this statement. Okay, that is in place, instead of writing it in terms of I, j, k, we have written it in terms of commas within the angle bracket. Okay, that's so a cap, that is a unit vector, becomes equal to angle bracket -2 by 7, comma 3 by 7, comma 6 by 7, and this is the end of our problem, our video. Till next video, Allah Hafiz. Okay.